Good morning, student. Today we are going to see our next topic, that is why TMS is used as a NMR solvent or reference material. So first of all, what is the full name of TMR? It is tetramethylsilane. Just look the structure of tetramethylsilane. Tetramethylsilane have 4 CH3 group, that is 4 methyl group in its structure, and all the proton, that is these 12 proton, are chemically equivalent. Therefore they give single peak. It have higher field absorption, that is scale selection is easier. It is easily dissolved in most of the organic solvent. It is very important property of this compound. It is highly volatile, that is it can easily remove after recording the spectra. Beside that, this compound not react with most of the organic molecule. That's why TMS is used as a reference material or NMR solvent. Now what are the factors affecting the position of peaks? There are several factors which affects the position of peak in NMR spectra. First factor is which type of proton your carbon have. So just see here, proton can be divided into 3 categories: primary, secondary and tertiary. Don't get confused. Primary protons means those protons which are present on primary carbon atom. Just see here, these 3 hydrogen present on primary carbon atom, its Dale value is 0.9. When proton present on secondary carbon atom, just see there is a gradual increase in Dale value. The Dale value increases, that is 1.2. In tertiary proton, or the proton which is present on tertiary carbon atom, again see its value gets increases. So which type of proton which type of proton is there, according to that the value, Dale value changes. For tertiary proton have highest value as compared to your primary and secondary. Now inductive effect, it is the most prominent effect and it have very significant role on your Dale value. Now what is inductive effect? If your carbon atom attached to any electron withdrawing group, then that electron withdrawing group draws electron towards it and de-shielding of proton on that carbon atom takes place. Just see here, in methyl chloride the Dale value is near about 3 because this chlorine have inductive effect on your carbon and carbon takes electron from hydrogen. That's why these protons are de-shielded. What happen when I change one of the hydrogen from this methyl with the chlorine? So we clear cut see the Dale value is increases and there is very high increase in the Dale value. Again if you replace one proton from here with a chlorine, Dale value is further increases. That is due to the inductive effect there is de-shielding of proton take place, which simply means that high Dale value. Now what is anisotropic effect? Important thing, anisotropic effect is observed only those compounds which have pi bonds. your pi bond generates the electron cloud, and that electron cloud generates its own magnetic field. This magnetic field of electron cloud basically have two effects. One is shielding and one is de-shielding effect, and this effect can be observed on the proton which are present on your molecule. So in a same molecule we get shielding and de-shielding effect in its different region, and that is simply known as anisotropic effect. If a proton comes in a shielding region of this effect, so shielding basically decreases del value, and if protons comes in a de-shielding effect of come in a de-shielding region, then proton have higher del values. Just see the example of benzene. It is the structure of benzene. In this structure, see, this is the electron cloud or delocalized electron in a benzene. It generates their own magnetic field, just like this, here and here. Just see the arrow of magnetic field which is generated by delocalized electron in benzene. The direction of magnetic field which is generated by delocalized electron is like this. Now see the proton on right hand side. This is the magnetic field of delocalized electron, and see the direction of applied magnetic field. So from here we clearly see that on right hand side your magnetic field of delocalized electron resonance force external magnetic field. So your right side proton are get de-shielded. So overall magnetic field experienced by these protons is higher. Same thing is happen on left hand side. These protons also experience higher overall effective magnetic field, because the magnetic field of delocalized electron resonance force external magnetic field. So hydrogen bonding. If proton is involved in hydrogen bonding, electron density decreases. For example, this is the molecule of ethyl alcohol. When another molecule of ethyl alcohol comes in contact with it, so these hydrogen which are present on oxygen comes under hydrogen bonding. So what going to be happen? Both the electronegative atom, that is oxygen, takes away electron, they pull the electron of hydrogen towards themselves, and that's why this hydrogen get deshielded. And we know that deshielding means high del value. So in simple word we can say that due to the hydrogen bonding, del value get increases. So this is the example. If you take a concentrated solution of alcohol, so in concentrated solution of alcohol there is hydrogen bonding, and that's why del value of proton which are present in OH group comes near about 4 to 5 del ppm. While if you take alcohol very less in less quantity in aprotic solvent, there is no hydrogen bonding takes place, and that's why del value of this proton comes at 1 ppm, because there is removal of hydrogen bonding. This is what overall effect of hydrogen bonding on proton. Now next topic is intensity of peak. Always remember that area under the peak is equivalent to the intensity of peak. Means from intensity of peak, area under the peak can be calculated. In actually area under this peak, it is very hard to calculate this area under the peak, but intensity of peak, that is height of peak, can easily calculated, and from that height a chemist is able to find out how much number of proton is present in that group. For example, ratio of intensity of peak is equal to the ratio of number of equivalent proton in the group. Intensity is directly proportional to the number of equivalent proton in that group. Just we are going to understand this statement. This is what a NMR spectrum of methyl alcohol, low resolution NMR spectrum of ethyl alcohol look likes. As we know that it have three different types of proton, it's give three signal, but what is the intensity of that peak? So just see here, this methyl have 3, that's why we write here 3. This CH2 have 2 proton, that's why 2 is written here, and this OH have 1 proton, that's why 1 is written here. That is ratio of intensity is 3:2:1. So when actual spectrum of ethyl alcohol is observed, it is observed that the peak height of OH, if have when actual spectrum of ethyl alcohol is observed, it is observed that peak height of this methyl is generally comes 3 times higher. For example, if OH peak height is 1 centimeter, so then methyl peak height is 3 centimeter. and that of CH2 peak height is 2 centimeter. That's why ratio is 3:2:1. From this information, a chemist is able to calculate number of equivalent proton easily present in that group. Now, what is spin-spin coupling or splitting of signal? Now, condition for spin-spin splitting: if two non-equivalent protons are present on adjacent carbon atoms, they affect signal of each other, and because of that the signal gets splitted. Each proton basically generates their own magnetic field. Then this magnetic field either resonance force or oppose the external magnetic field, which is filled by adjacent proton. What we want to say that, just see the example here. This is the molecule 1,1,2-dibromoethane. This molecule have two different types of proton, that is HA and HB. So number of signal obtained in this molecule is 2. So number of signal which obtained in this molecule, it is 2, just like this. And intensity ratio is what? Since this carbon have 2 proton, that's why 2, and this carbon have 1 proton, that's why 1. 2:1. So one peak should get high and another peak should get low. Now we are going to discuss about HA proton, or just first we discuss HB proton. Just see here, HA proton is present on adjacent carbon atom on this carbon. Because of that, HA can generate its own magnetic field. So due to spinning of this proton, magnetic field of this proton, either HA can oppose the external magnetic field or it resonance force the magnetic field which is experienced by HB proton, and this is known as coupling. And these are 50-50 possibility. Either HB experience less overall effective magnetic field due to HA, or HB experience overall high magnetic field due to HA. both is equal possibility. So the signal of Hb proton is split up into two equal half. So signal of Hb proton, single signal of Hb proton is observed like this in a spectrum. So splitting of this signal, this peak takes place like this. So now consider effect of Hb proton on Ha. So first of all, number of Hb proton is 2. So this is your external magnetic field which is applied. Now we are going to see what happens with signal of Ha proton. Since number of proton of Hb is 2, either both the proton oppose magnetic field or both the proton Hb resonance force magnetic field, and there is also a third possibility that one of the proton assists magnetic field and another proton oppose the magnetic field. For our standing, just mark any Hb proton as H1. So I write this is H1. In this possibility, we see that Hb1 proton oppose the magnetic field while Hb proton assists the magnetic field. There is also one combination can be written. Hb1 proton can assist magnetic field while Hb proton can oppose the magnetic field. So what is overall intensity ratio? So this is 1, 1 plus 1 is 2, and this is 1. So intensity of splitting for Ha proton is 1:2:1, and splitting pattern is triplet. Why it is triplet? Because Because there are 3 possible combination by which Hb can couple with Ha. So Ha signal can be splitted into triplet, and intensity of that triplet is 1:2:1, that is 1 2 3, and this is 1:1. So this is the actual spectrum of your this molecule, that is 1,1,2 dibromoethane. So always remember, splitting takes place in this fashion. So just look here. Here in this diagram, we observe the effect of Ha proton on your Hb proton. So in a external magnetic field, your Ha proton can either assist this magnetic field or reinforce this magnetic field, and because of this proton magnetic field, your Hb proton either feel higher effective magnetic field or either it feel overall magnetic field lesser, and this is exactly a 50-50 percentage probability, that therefore it is 1:1 intensity ratio in splitting pattern. So this is what external magnetic field, and this is what uncoupled Ha. When now there are two proton, Hb, which is present in 1,1,2 dibromoethane. So what going to be happen? Either both Hb proton oppose the external magnetic field, or they both assist the external magnetic field, or there is also one possibility, one can assist, another one can reinforce, and in this case there is also another possibility which is written like this. So due to the effect, due to the magnetic field of Hb proton, Ha proton either feel overall higher magnetic field, or it is filled overall less magnetic field, and that's why this phenomenon is generally known as coupling, spin-spin coupling. In our next class, we are going to see what are the conditions for spin-spin coupling. Thank you.